Hi, I'm Mark Rosenzweig, editor of Chemical Processing magazine. The presidential nominating process is bringing out political pundits everywhere, so let me join in too. I predict that the next president of the United States will push for concerted action against greenhouse gas emissions. Actually, that prediction doesn't take much punditry prowess. Senator Hillary Clinton, former Governor Mike Huckabee, Senator John McCain, and Senator Barack Obama all support a cap-and-trade approach to controlling carbon dioxide and other greenhouse gases. Such an approach basically imposes a cap, likely at a lower level than current emissions. This amount of allowable pollution then is apportioned via individual permits that companies can trade. Backers say the approach provides flexibility as well as financial incentives because firms that reduce emissions can sell the permits they don't need. Any move towards cap and trade clearly will have a profound impact on chemical makers. The industry, which has already made impressive strides in paring pollution from plants, as we covered in our October issue, undoubtedly will have to ratchet up its efforts. The limits on greenhouse gas emissions also will provide business opportunities, a fact certainly not lost on some chemical companies. For instance, in mid-February, Dow Chemical Midland, Michigan signed an agreement with the French company Alstom Power to jointly develop and commercialize an advanced amine scrubbing system to remove CO2 from low-pressure flue gases from fossil fuel-powered power plants and other installations. This follows an August 2007 pact between BP Alternative Energy, London, and Powerspan Corporation of Portsmouth, New Hampshire, to collaboratively develop Powerspan's Echo-2 ammonia-based CO2 capture technology for power stations. Construction of a pilot unit at a generating plant in Shadyside, Ohio has begun, and first results are expected this summer. Better membrane technology also may improve CO2 removal from power plant flue gas. For instance, polymer membranes with hourglass-shaped pores being developed at the University of Texas at Austin promise high permeability with high selectivity. More details are in our November issue. They suit separation of CO2 from natural gas as well. Significant efforts are occurring worldwide. For instance, Abu Dhabi in the United Arab Emirates now is planning the world's largest carbon capture and storage project. State-owned Abu Dhabi Future Energy Company intends to invest as much as $4 billion to retrieve up to 15 million metric tons of CO2 each year from 8 plants. The gas then would be injected underground to enhance oil recovery. Long-term storage or sequestration of CO2 is a major issue in its own right. In the U.S., injection into oil reservoirs may provide an attractive option to deal with some of the CO2. However, such reservoirs won't make sense for much of the massive volume of CO2 that would be captured each year. Other options include use of salt domes and depleted coal seams. Geologic sequestration poses all sorts of challenges and risks because of Mother Nature. Release of CO2 from a layer at the bottom of a lake in the African nation of Cameroon, caused perhaps by a landslide, led to the death of 1,700 people by asphyxiation, as Sean Ottewell related in our March issue. So successfully grappling with greenhouse gases demands far more than political will.